Okay, so the notes over quartic functions N26, x to the 4th power. All right, let's graph that parent function. Make yourself a t-chart. Okay, these are going to be the basic points that form the parent function. Okay, I always start with -2, -1, 0, 1, and 2. Okay, -2 to the 4th power is 16. So -2 all the way up to 16. I'll just put it way up high. Okay, -1 squared is 1. So -1, 1. Okay, 0 to the 4th power is 0. And then 1 to the 4th power is 1. And then 2 to the 4th power is positive 16 again. So you can kind of see that x to the 4th kind of looks like a really skinny parabola. Okay? Now, since this is the parent function, and 0, 0 is going to represent a quadruple root. Okay? Any polynomial to the 4th power is going to have 4 roots. Okay? Which means 4 factors. All right, so just keep that in mind, how that looks. All right, the same steps we followed for cubic, we're going to follow for the quartic. Sketch the function from factored form. So solve for x on each factor, and then plug in x equals 0. Okay, so solve for x each factor. Okay, and then you're going to want to test some values to determine the direction of the function. All right, so for example, number 1 here. Each factor, x minus 4, equals 0, so x is positive 4. Okay, x plus 2 equals 0, so x equals negative 2. All right, x minus 1 equals 0, x equals 1, x minus 5 equals 0, x equals 5. Okay, once you get your roots determined, then you need to figure out where is it going to cross y. Okay, so once you plug in 0 for all your x's, then you'll know where it's going to cross y. So y-intercept 0 minus 4 times 0 plus 2 times 0 minus 1 times 0 minus 5. Okay, so that's negative 4 times 2, which is negative 8. Okay, and then negative 8 times negative 1 positive 8, and 8 times negative 5 is negative 40. Okay, so my graph is going to cross the y-axis at negative 40. I'm just going to put that on there, way down low. All right, since this is a quartic function, I know it's going to cross the x-axis 4 times, and I already have the 4 roots there where it's going to cross. I just need to know how the graph's going to behave. So I'm going to pick a point out here. I'm just going to choose negative 3 because it's easy. All right, and then I'm going to choose a number between negative 2 and positive 1. I think I'll choose 0. Oh, no, I'm not going to choose 0. What am I thinking? That's the y-intercept. How about negative 1? We'll choose negative 1. Then we'll choose a point between 1 and 4. How about 2? And then we need to choose a point out here. How about 6? All right, so let's think about this a second. If my graph is going to cross at negative 2 and positive 1, do I really need to test the negative 1? Okay, no, I don't need to, because how else am I going to get down here to negative 40 unless I go down, right? So I don't really need to test that point because I know the behavior there. Okay, All right, let's plug in -3 for all the x's. -3 minus 4, that's going to give me a negative number. Okay, -3 plus 2 is going to give me a negative number. -3 minus 1, negative, and -3 minus 5, negative. So when you multiply 4 negatives, what do you get? Negative times negative times negative is positive, right? So that means if I plug in x equals -3, the point is a positive answer. So my graph comes in from above up here. Okay? All right, now I'm going to plug in 2 to the graph, or to the function. Let's see what we get there. 2 minus 4 is negative. 2 plus 2 is positive. 2 minus 1 is positive. And 2 minus 5 is negative. Okay, so is it going to be above or below? Above, because negative times negative is positive, and everything else is positive. So between 1 and 4, the points are all going to be up here. So that means I need to go up somehow like that. Does that make sense? Okay. All right, so it's going to cross 5. 5 is going to be a root, right? And then, so let's choose 6 here. Let's see what that's going to be. All right, so 6 minus 4 is positive. Okay, 6 plus 2, 6 minus 1, and 6 minus 5. So out here, all my points are going to be up high, right? So it's going to come up like that. And this one, I could make it more like that. So it kind of looks like a W in a way. Kind of look at it. All right, y'all have any questions? Why don't you go ahead and let's graph it and see if we got the shape correct or not. Okay, somebody read it back to me. X minus 4. X plus 2. X minus 1. X minus 5. There we go. Graph it. So we got it pretty right, didn't we? Okay, I could have came down a little bit lower, but in this lesson, we didn't really calculate what the minimum was. We'll do that on in another lesson next week. So for now, all you need to know is just to get your roots correct, and get your y-intercept correct, and get your direction correct. All right, we're going to skip over to number 3. Number 3 has a double root. X minus 2 equals 0. X equals 2. So at x equals 2, we have a double root. Okay, when you have a double root, I want you to look for a behavior in the graph where it bounces back the other way. You might think it's going a certain way, but when there's a double root, it's going to bounce back the other way. Okay? All right, the other roots are x plus 3, so the root is at -3, and x plus 2, so it's going to be at -2. I'm going to spread those apart a little bit better. Okay? All right, let's plug in 0 for x so we can get our y-intercept. Okay, 0 minus 2 is -2. -2 squared is +4. Okay, 4 times 3 times 2 gives us 24. Okay, so way up here at 24, the graph's going to cross y. Okay, so I know that I need to connect -2 to the y-intercept for sure, and then back to 2. Okay, but everything else, I'm going to go ahead and plug in a test point to see. Now, where was the double root? Right here. So It kind of looks like it's going to keep going below, but I'm going to predict it's going to go back up because that's a double root. Okay, so let's choose 3 to make sure that we're correct. Okay, 3 minus 2 is a positive number, right? And you square it and it's still positive. 3 plus 3 is positive, and 3 plus 2 is positive. So sure enough, the points are going to be above the line. So that was correct. All right, now the behavior over here on the left, okay, somewhere between -2 and -3. So -2.5 minus 2. Is that going to be what is that going to be? Negative, but then you square it, and it's going to be positive, isn't it, when you square a negative? All right, -2.5 plus 3. Positive, because 3 is bigger than 2.5. And then -2.5 plus 2. That's going to be negative, right? It's 2.5. So positive times negative. So in between these two roots, it needs to come down. Okay? So we've crossed at 1, 2, 3, and this is going to be considered the 4th root here. All right, so plug in, what, -4? -4 minus 2 is negative, but you square a negative and you get positive. Okay, -4 plus 3 and -4 plus 2. So it's going to keep going up, isn't it? It looks like a W again. All right, number 4, if you notice we have a triple root. Do you think with triple roots, does it bounce back up?
No, it just splits through it.
Do you think it's just going to keep going? All right, let's see what it looks like. Okay, where's the triple root? At +2. So that's going to count for 3 roots, and the other root is at -1. Okay, and where's my y-intercept going to be?
0 minus 2 times
So 2 to the 3rd power is 8, right? -2 to the 3rd power is -8, but negative times negative is positive, so this is at 8. Okay, so it's going to go all the way up here. So we know it's going to have to do this number. Okay, I just need to know what's it going to do on the other side of -1. So what number y'all want to choose? Okay. All right, so negative, and then you got -2 minus 2 is what? And -4 cubed, is it going to be positive or negative? It's going to still be negative, because if you have an odd number for your exponent, okay, and then -2 plus 1 is negative. So negative times negative times negative is negative, isn't it? What's going to go down? Okay, what's going to happen over here?
It's going to just like split through.
Well, let's see. Negative for the negative in front. Okay, 3 minus 2 is a positive number. And then 3 plus 1 is a positive number. So negative times positive times positive. Now it kind of looks like a parabola in a way, but I want to point something out to you guys.
It curves through it.
Yeah. You know how the double roots will bounce back another direction? Well, cube roots do have a quirky little thing too. Right where your triple root is, it kind of flattens out before it goes down. It has like a little flat little space, and that's kind of what it always does. Okay? And if you need to, you can graph them. You'll have a calculator for this type of problem on your test. So.